In this video, we're going to have a look at SAT practice problems for the year 2001. 5 practice problems today on High Peak Education. What's going on, everybody? Hope you're having a wonderful day. And we have 5 practice problems today for which we will show the full solutions. And I warn you that the 5th one is somewhat long. It's about a 9.5 out of 10 in terms of the difficulty. But otherwise, these are the types of problems you need to know how to do to be successful on the SAT exam. They are problems from Heart of Algebra and Passport to Advanced Math, which is basically upper or advanced algebra. So in order for you to succeed on the math section, you're going to need to know how to do these problems, to be able to work through, understand them, and they're all explained as we discuss. So let's get into today's content. So we have b equals 2.35 plus 0.25x. C equals 1.75 plus 0.40x. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? Okay, so when the two prices are equal, what should we do with the two equations?
Set them equal to each other?
Nice. Set equal to one another so that we find the week X where the prices were exactly equal. You could say 2.35 plus 0.25x equals 1.75 plus 0.40x.
We subtracted 1.75 and the 0.25.
So let's subtract 1.75 from both sides. And then you're also saying let's subtract 0.25x from both sides.
Yeah.
Okay, that should be fine. All right, so let's see what happens. We got, first of all, with the x's, 0.40x minus 0.25x. I think it'd be 0.15x. Would you agree? Okay. And then what's 2.35 minus 1.75? So 5 minus 5 is 0.
Right.
3 you can't take away 7, so let's make that a...
It's going to be 60 cents.
Yeah, 0.60. Yeah, exactly. And then how do we solve for x?
Both sides by 0.15.
Mm-hmm. Okay. What should we get for x?
Oh, I'm putting that into my calculator.
Okay.
Is it 0.6?
0.6 over 0.15.
4.
Yeah, 4. Now, by the way, if you didn't know that quite so quickly, it's okay, but notice that you can multiply the numerator and the denominator by the same number to get rid of decimals. You can multiply them each by 100, and I would recommend that because that would just be 60 over 15. Now, 60 over 15 is a lot easier to divide, right?
Right, yeah.
Just be 4. But either way, x is 4. So it's 4 weeks after July 1st, right? Now, that's not the answer because they're looking for what was the price of a pound of beef. Well, what was the price then? How can we actually find the price of a pound of beef at that moment?
Put 4 in for x.
Yeah, that looks good. So B should be 2.35 plus 0.25 times 4 for x. Now, what's 0.25 times 4 by order of operations? Yes. So this right here gives 1. And then so we need 2.35 plus 1, right?
2.35.
It's going to be like dollars, right? $3.35, which is which choice? So I think D should be the right answer. Which of the following numbers is not a solution of the inequality 3x minus 5 greater than or equal to 4x minus 3?
I don't know how to do this.
Okay, so there's one of two ways. The longer, I would say the longer method, but at least the more thorough method, is to solve the inequality. But the second method, and this is if you're really stuck, you can always plug in what? Yeah, you can plug in the answer choices and see which works.
Right. That would be like putting -1 in for x and then
-7.
-7, yeah.
Yeah, so is that true?
Yes.
Well, is -8 greater than -7?
Oh, no, it's not true.
Correct. So that's why choice A is going to be the correct answer, because they're saying not a solution of this. Okay, you got to be careful. Whenever they capitalize something, you have to be very careful of that word. Okay, not a solution. Well, if you plug in -2, what would you get? You'd have, let's see, -6 minus 5, that's -11. And then if you put in
that would be -11.
Yes, -11.
So that would make it equal to each other.
Right, so that would be a solution, right? Okay, and it turns out if you do the rest of these, you'll see that the rest of these are also incorrect. Okay, so that's one way. You can always plug in the answers if you don't know how to solve this. The way I would do this is I would solve the inequality. So 3x minus 5 greater than or equal to 4x minus 3. Basically, you could subtract 3x from both sides. Treat the inequality almost like an equal sign. And you would get -5 greater than or equal to x minus 3. And then you could add 3 to both sides. So you're going to...
about the test.
Okay, sure, go ahead. I think what it is that you can write on your test booklet, but you can't write on the answer sheet. The answer sheet's only for bubbling your answers. So anyway, do you see what I did? I added 3 to both sides, and I've got x, -2 less than or greater than or equal to x. Another way to say this is x less than or equal to -2, because like the inequality is still pointing the same direction. But look, if x is less than or equal to -2, then all of these are valid. -2, -3, -5, right? Because those all fit. But -1 does not. So that's why -1 is the correct answer for not in the solution set. Does that make sense? Okay. Yeah, I would say it's basic algebra. It's nothing with quadratics or anything. So you figure it's just like, it's stuff you did previous years in algebra. Okay.
Like algebra 1.
Mostly algebra 1. Yep. All right, let's have a look at this one. It says a line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? 0, 7, 1, 7, 7, 7, or 14, 2. So the xy plane is just a fancy way of saying you've got x and y axis.
That's annoying. That's confusing.
Okay, so but the thing is, a plane is like a flat piece of paper where anywhere is possible.
Yeah, 1, 7 lies on the line.
Incorrect. Notice that one of the things you got to notice about the SAT is they're always going to have, listen to me carefully, distractor answers. This is a classic distractor.
If it passes through the origin, then it goes up 1, 2, 3, 4, 5, 6, 7.
1, 2, 3, 4, 5, 6, 7, right? So what would that point be if you labeled it?
And 1, right.
Do you see why this is incorrect? This is a distractor. Yes. Because you just go one more up here, right? You go over to here.
In general, I always get the X and Y like mixed up. Like I know which is which.
Right. No, I understand what you mean, and just be careful on that. But the other thing I was going to briefly say is on the SAT exam, you're under a bit of time pressure. And since it's a timed exam, what I'm getting at is it's very common to make a mistake like choose choice B there on this problem. So just be careful to not do that, because there's always going to be choices that are distractors. You understand what I mean?
Yeah, I don't think they should make the SAT time test because some people do way worse at a time.
One of the most common things on the SAT exam, and listen to this is an important test-taking strategy, is they'll often put they'll introduce another letter. Well, kind of. Given that they introduce another letter, it makes the problem look really hard by introducing another letter.
That's a basic problem, right?
Yeah. So basically, we have this important fact: g of 4 equals 8. So let's write that down. G of 4 equals 8. Well, you have to put in for x to then find a.
Or -4 in this case.
Yep, so let's start off with 4, right? So we go 4 squared plus 24. The answer is going to be no. We need to work this part of the problem through to find a. The fact they gave us g of 4 equals 8.
Right.
So they gave us this, and then now we're plugging in, and then now we're going to solve this for a. Okay, so one step at a time. What's 4 squared? So we have 16a plus 24 equals 8. So we need to solve this for a.
40.
Well, we can't because we don't know what a is.
Okay.
So you have to subtract 24 from both sides. Well, 16a, we need 8 minus 24, which is what?
Is -16.
There we go. And then now we
divide both sides by 16.
Yes, there we go.
So that'd be -1. Oh! So...
And then now that we have a, can you evaluate g of -4? You plug in -4 and you also plug in a, right?
Oh,
So
the answer is -1.
So it's -1. Well, the answer is not -1 because remember, this is another distractor.
And you'd be doing the same problem exactly. Oh, there would be nothing on the other side.
Right. So you just get 8. Do you see that? Okay, so look, a is negative. We only subtracted 24 from both sides to find a. We knew what the value of the function was. Okay, so a couple thoughts. First of all, don't just try to guess that if one is 8, the other one's -8. Okay, that would be incorrect. Secondly, -1 is not the answer because yes, -1 is the answer for a, but it's not what they were asking for. So this is not what asked for. And then if you plug in -4 and a, you can find the y value. In other words, you can find the function value. So that's what they are asking for. Now it turns out if you graph a function like this without going into a lot of detail, hopefully you remember that a function like this should have a vertex up at its maximum value, which in this case would be 0, 24. That's because in this case, all we've done is we've taken the parabola and shifted it up 24 units. And it turns out this is symmetric to the y-axis. It's basically an even function. So when we look at g of 4, we get 8. When we look at g of -4, we also get 8. Do you see that?
Yes.
So the thing is, you could have maybe solved this a little faster if you also realized that. Does that make sense?
Yes.
So there's a couple ways to solve this, but that's one way. If ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of x, and a plus b equals 8, what are the two possible values for c? Okay, a and b can be anything, and you just have to add up to 8. If a is
-8, positive 8.
not necessarily. If b is 20, a could be -20. A could be -12. You see what I'm saying?
Yeah.
That works too. But listen to what I'm saying. Whenever you have multiple letters, it's easy to try to just start hacking away at it. Try to think about it logically. So a plus b equals 8 is an additional fact they give us. They're basically saying, look, here's another fact. But we should be able to determine certain things from the above equation.
Okay.
Now look at the equation on the left. Do you see that you've got ax plus 2 times bx plus 7? If you were to use something that you learned in algebra, what would you do if you multiplied these binomials out? Yeah, you'd FOIL those out, right?
Right.
Now, by the way, do you see that if we FOIL this out without like multiplying it out just yet, just let your brain go to multiplying it out is going to give you a quadratic term, that's an x squared. It's going to give you a linear term, that's an x, and then a constant term. By the way, do you see when you get to L and FOIL, you're going to have 2 times 7, you're going to get this 14 on the right-hand side.
Right.
So basically what I'm trying to say is that if you FOIL this out, you're going to have to use the letters and follow the pattern, but you should be able to match things from the left-hand side to the right-hand side. So the idea is that if we FOIL, we should be able to match coefficients across the equation, okay? So let's try it. What happens when we FOIL this out? What's ax times bx?
ABX squared.
Right, because a times b, alphabetical order, x times x, right? Then we need to do outer, so that's ax times 7, which is what?
X times 7, that's going to be 7ax.
7ax, I agree. Let's keep moving. What's going to be 2 times bx? 2bx, right?
Oh, right, yeah.
2, we'll get the number out front, b is a constant, x. And then finally, what's 2 times 7? Yep.
Oh, 14.
Yep, 14. You okay with all that?
Yeah.
So this is what proceeds after foiling, right? Do you see that this is equal to, well, 15x squared plus cx plus 14. Okay, now the reason I mentioned this is because we already said we want to match coefficients across the equation. First of all, what number do you see is the same on both sides of the equation that we can just immediately get rid of? Yeah, we can just subtract off 14, right? It's completely irrelevant. You see that? Right, we're trying to find variables. But then, what proceeds on the on the right-hand side is still 15x squared plus cx. Now here, I think we should do something kind of special with these two x terms. So let's put these together. Yeah, we can, but we have to be, not going to be x squared, they're both x's. Exactly, 7a plus times x. Okay, and then we still have the ab x squared out front.
I feel like we're just making it a lot more complicated.
Actually, it looks complicated, but now's the moment it becomes not complicated. Okay, you ready? Watch this. Here we have AB on the quadratic term. What do we have on this quadratic term? So we could say AB equals what? 15. Do you see that?
No.
Okay.
Oh, wait. Yes.
Because look, both sides have x squared terms. So the coefficients must be equal. Therefore, AB must equal 15. Do you see that? Okay. Let's try another one. In a very similar way, 7a plus 2b should equal to what? Yeah, there you go. 7a plus 2b has to equal c. Okay, so here's the deal. When you multiply out the terms on the left-hand side, when you FOIL, you get quadratic terms, you get linear terms, and you get constant terms. We were able to cancel the constant terms, right? The positive 14s, we were able to subtract 14 from both sides. We could just make those go away, right?
Right.
So what that means is the two terms that are on the left that remain, ab x squared and 7a plus 2b times x, have to equal 15x squared plus cx. But notice that that really means the coefficients must be the same, because we can match them. What I'm trying to say is that this entire term and this entire term must be the same as each other. This and this must be the same. ABX squared must be the same thing as 15x squared. So that means the x squareds are obviously the same. So the only thing that's not the same, or, you know, we could write down is a times b is equal to 15. same thing can be said about here. This term and this term must be the same. Do you see that? So that means the x's are clearly the same, but then 7a plus 2b, which is out front of the x, must be the same thing as c. So 7a plus 2b must be the same thing as the c. Okay? Now, one last thing. They also gave us that a plus b equals 8. Do you see that?
Yes.
So I might as well write that down. A plus b equals 8. Now, if you think about it, we don't need to consider x's any longer. We have 3 equations, and how many unknown variables do we have?
3?
3 unknown variables. A, B, and C. Would you agree? A, B, and C. Okay, so what I'm trying to say is this. If we can substitute things into here, either if we find A or find B, and then we can find C, or we need to get C in terms of A and B. I mean, basically, we need to get the various values of C. But in order to do that, I think we're going to need to get values of A and B and that kind of thing. Does that make sense or no?
Yeah.
Let's think about our plan of attack. Our plan of attack could be like, notice the goal is C. Would you agree with that?
Yes.
The goal is letter C. We don't really care about the other variables. So, do you see that C is in terms of both A and B?
Yeah.
That's this equation. It's in terms of A and B. So we'd like to get that only in terms of one variable. So in other words, I'd like to get 2b in terms of A. Would you agree with that?
Yeah.
Because this 2b right here, it'd be nice to get it in terms of A. Well, there is a relatively easy way to get that in terms of A. That'd be what? Well, you could take the green equation, the third equation, and multiply by what to get a 2b? Multiply by 2. Because you multiply 2 times A plus B, that should be 2 times 8. So that's 2A plus 2B. We're using the distributive property. And then what is 2 times 8? 16. Yep. So then we want to go, let's see, 2B equals 16 minus 2A. You see that? And just like we said, 2b is 16 minus 2a, and that can go in here. So then we're going to rewrite, and by the way, we could call these equations 1, 2, and 3. We're going to rewrite equation 2 in terms of a only on the left-hand side. See what I'm getting at? On the left-hand side, we're only going to have A's. So we should have 7A, and then remember, 2B becomes 16 minus 2A. So this is plus 16 minus 2A equals C, correct?
Yeah.
Now, the 7A and the minus 2A can go together. That's 5A plus 16 equals C, right? Because just 7A minus 2A. Then we need to say, well, look, we can't quite get the answer yet because we don't have A. So the thing is, let's call this equation 4. Let's call this equation 5, okay? We're just labeling things. Equation 4 was 2b equals 16 minus 2a, and equation 5 is 5a plus 16 equals c. So do you see that from equation 5, we need a, right? So
Yeah.
we don't have variable a. So the only pair of equations we haven't used is equation 1 and 3, because we've already used 2 and 3. Would you agree?
Yes.
We used equation 2, we multiplied equation 3 by the number 2, we plugged it in. So we've already used this pair. We now need to use equation 1 and Well, if we're going to use equation 1 and 3, again, we want to find A, and we don't care about B. We don't care. So we want to replace B. So if we want A, then we want to say that B equals 15 divided by A. Do you agree with that?
Yeah.
15 divided by A, because that's just from equation 1. So from equation 1. Now that, let's call this, I don't know, 6, and then we'll put 6 into equation 3. Which again, equation 3, you got to keep it straight. Equation 3 has A's and B's. We'll be able to get A by itself. So this will become A plus, now remember where B is. It's going in there, right? So A plus 15 over A equals 8. Do you see how we got that?
Yeah.
Okay, now we need to solve this for A, because we already said that, right? We need to find A. So how are we going to do that? Well, let's first multiply the entire equation by the least common denominator. Which is the least common denominator here?
Oh, A?
A. So let's multiply everything by A. So if we multiply everything by A, we have to distribute over here, and then we just get 8 times A. So we get A squared plus, and that's 15 over A times A is 15, equals 8A, correct? And then we need to get this in standard form. So this is A squared minus 8A plus 15 equals 0. Okay, we've seen this many times before. This is a quadratic. It's also a trinomial. So remember what we've said many times. This is a trinomial with 2 factors. So we need to say, give me 2 factors of positive 15 that add up to negative 8, right?
Right.
2 factors of positive 15 that add up to negative 8. What would they be? 3 and 5, yeah. So you're saying A minus 3 and A minus 5 equals 0, right? So those are the 2 binomial factors. A minus 3 times A minus 5. Okay, so it turns out, believe it or not, we're actually very close. So we're actually very, very close. What are the 2 values that A could be? Yeah, A equals 3 or A equals 5. Okay? So if that's the case, A equals 3 or A equals 5, then we need to plug those back into which equation? Equation 5. Do you see this? Because we need to find C.
Okay.
So that's the idea. Let's plug into equation 5. So let me write this down. So let's just say return to equation 5. Use the A's to find the C's. But anyway, here's equation 5. You see it?
Yes.
So let's call this the first value of A, A1. So if we do A1, the first value of A, that's going to be 5 times 3 plus 16. And that's going to equal C. Well, what is 5 times 3?
15.
Yep, so we've got 15 plus 16, which is what number? 31. So that's one of our answers to the problem for C. But then we have to do for A2. A2, we're going to do 5 times, this time 5, plus 16 equals C. So what's 5 times 5? 25 plus 16 equals, and what is that? 41. And notice those are the 2 values of C. 31 or 41. And then now let's go back to the problem. Which is the correct choice? So the correct choice is choice D. Okay. Now, by the way, in my opinion, I think it's hard to see the forest for the trees, given how many steps that was. So why don't we kind of go back to the beginning and briefly review what we did? Okay?
All right.
So what did we do? We said If we FOIL out the left-hand side here, we think that we can match coefficients across the equation. Okay? So if we FOIL, first, outer, inner, last, that's what we did here, right? So we FOILed, and we got these terms, abx squared plus 7ax plus 2bx plus 14. And that equals still the right-hand side, 15x squared plus cx plus 14. We're able to cancel the constant terms because they're both just the same, right?
Right.
So these were both the same, and we're just able to subtract them off. So we get abx squared plus, and then here what do? We actually factor out the x on the right. So we factored out the x on the right, and we've got 7a plus 2b times x on the right is equal to c times x. But then abx squared has to equal to 15x squared. Because again, we're just equating left-hand and right-hand side of the equation. Because if everything's equal, something has to equal something. So we can deduce from that, what's in red, AB has to equal 15. That's here. That we're calling equation 1. 7a plus 2b has to equal c. That we're calling equation 2. And then lastly, in the problem itself, they gave us a third equation, which relates a and b together. They said a plus b equals 8. This is 3 equations and 3 unknown variables. The unknown variables are a, b, and c. Do you agree with that?
Yes.
So that can be solved because we have enough equations for as many unknowns as we have. So we wrote them down. The goal is C, letter C. Now, in order to find letter C, there's a couple ways to do this, but the one way I thought of is if you combine equations 2 and 3, you can get 2b, which is in the C equation, 2b in terms of a. So we're going to multiply by 2.
Okay.
We're going to distribute the 2. And then, by the way, when I say multiply, we multiply the entire equation by 2, right?
Right.
And then we distributed the 2. 2 times 8, though, is 16. We solved for 2b. We substituted it in for 2b. So
Okay.
we're going to substitute 16 minus 2a into the 2b slot. So we get 7a plus 16 minus 2a equals c. But that's if you do like terms. If you do like terms, then that's 5a plus 16 is c. So we're still not there yet because we still don't have a. Now we need to use equation 1 and equation 3 because equation 1 is the only equation we haven't used so far.
Okay.
So if you solve we solve equation 1 for b, and again, we're going to substitute into equation 3. What am I saying? Substitute into equation 3. So we put equation 6 into equation 3. We got a plus 15 over a. Remember, because b is 15 over a, equals
Right.
8. We multiplied by the least common denominator, which was a.
Right.
We distributed here. 8 times a is just 8a. We got a squared plus 15. Then we moved the 8a over for standard form. We factored by saying, give me 2 factors of positive 15 that add up to negative 8, which would be negative 3 and negative 5. Then we found the values. So these are the values or the roots. And then finally, we return to equation 5, which was the C equation, but it's already in terms of A to find the C's. So what we're doing is we're returning to this equation here, and we're saying, let's plug in A1 and A2. A1 is 3. We plug it in, we get 31. Use order of operations. We use A2, which is 5. We plug it in, use order of operations, we get 41. We look back and we find that that is choice D. We write down choice D and we jump for joy. I mean, I wish it was easier, but that's how we have to do it. Okay, by the way, like I said, this is about a 9.5 out of 10 in terms of difficulty. Okay, so if you understand that problem, then I think you are pretty actually set for a bunch of stuff on the exam.
So hopefully you really understand these problems. You understand that there are multiple ways to do many of these problems, that you really should not guess. You should only take an educated guess if you can eliminate more than one of the choices and that you have a good reason. Also, be careful to read the problems very closely. If the word not is capitalized, make sure to pay attention to that. Also, if some problems seem really long, like problem number 5, understand that the SAT is for a very large group of students. It's standardized, and it has to separate out the exceptional students from even those that are well above average. So if it's a very difficult problem, there's no shame in skipping a problem, maybe coming back to it, but now you know how to do even the difficult problem like we had in problem number 5, which was multi-step. But hopefully you see that there are also distractor answers. There are going to be choices which look correct but are slightly incorrect. So make sure you're paying attention to those, and I went over those several times today in the problems that we did. So understand that the SAT is going to measure your ability not just to understand math, but to be clever and to take a test well. So make sure you're prepared. And we'll be releasing more of these videos in the not too distant future, so stay tuned. And thank you for watching High Peak Education. Please smash that like button if you enjoyed this content. Please let us know in the comments how you're going to use this content for your life and then also in preparing for the SAT exam. We welcome your feedback. Social media links are also down in the description box below. Please support us on Patreon. Thank you for watching, and we look forward to seeing you in the next video.